Hello students, welcome to Gharisala. Today I am going to solve one more problem, and this is problem from monotonic function, right? So here we have a function which is defined from the set of real number. This is capital R stands set of real number, this R to R, right? And the fx equal to, within round bracket, 2 minus sine 1 upon x into modulus of x when x does not equal to 0, and the value of the function will be 0 when x equal to 0, right? So now there are four options we have here. This function will be monotonic on 0 comma infinite only, right? Second point is that here not monotonic on 0 comma infinite and minus infinite comma 0. Third option, monotonic on minus infinite comma 0 only. And fourth one, monotonic on minus infinite comma 0 and 0 comma infinite. This union, right? I think you know very well how to take the union of two sets, and these interval is also a set, right? So now, first of all, which approach I am going to use here, let me tell you, right? Monotonic, right? This is a special type of function. There are four categories I am telling you here. First one, that is monotonic sorry monotonic, right? Increasing in increasing, right? These are, there are two types again here. First, this is first strictly monotonic increasing. Monotonic increasing, right? This is what non-decreasing. Non-decreasing function, right? Similarly, you can replace here increasing by decreasing, right? So in this case you can write here strictly monotonic decreasing, right? In this case non-increasing, this will be non-increasing, right? So there are four categories in monotonicity, right? Now we come to the problem we have here. Here we use here modulus function. This, according to definition of the modulus function, we have first when x, the value of modulus of x equal to x, when x greater than or equal to 0, value will be 0 if x equal to 0, right? Now let me tell you here, we have function here fx. Now I will break my function in 3 points where s greater than 0, x less than 0 and x equal to 0, right? So this becomes 2 minus sine 1 upon x into x when x greater than 0, right? And this will be 0 when 0, and this will be minus 2 minus sine 1 upon x into x when x less than 0. I break the function. Now, how will check the function is monotonic or not? So let me tell you. Here we use now if f dash x means derivative of f greater than 0 for all x belongs to R, or all belongs to R stands for set of real number, then this function is strictly increasing, monotonic, strictly increasing. Next here, f dash x greater than or equal to 0 for all x belongs to R, then this is what? Non-decreasing. And for third one, if f dash x less than 0, this is called, for all x belongs to R, is called strictly decreasing, right? This is called strictly decreasing. Now if I write here f dash x less than or equal to 0 for all x belongs to R, this is called non what? Increasing. Four category view. So what I do in this case, I will just take the derivative of this function, right? Oh. Now first I take the case here x greater than 0. So in this case we have f of x equal to, within bracket, 2 minus sine 1 upon x, right, into x. Now you can see here there are two functions. This is a product of two functions. First I consider this and second. This is first and this is second. So we use the product rule of the division. So here f dash x equal to what? First I have to make differentiate this function first. So in this case what will happen? First 0 minus cos 1 upon x. Again you have to take the derivative of 1 upon x. This is minus 1 upon x square, right, into x, plus 10 take the derivative of x, that is 1, into the original function 2 minus sine 1 upon x. Now you can simplify here, this minus plus we have here, and this 1x and this x cancel. We have 1 upon x cos 1 upon x, right? Second thing we have here 2 minus sine 1 upon x, right? Now in this case I have to look here, we are using the value of x greater than 0, right? So what in this case, can you consider this function always gives you a positive value or negative value, right? Okay, consider, you can say x less than 0, then what we have? Then f dash x equal to what we have? F dash x equal to, you can consider again here, take the derivative of this with minus sign, right? So in this case what we have? In this case first I am consider, if I consider here d dx of, now listen, minus 2 minus sine 1 upon x, right, into x, to the derivative of this function, right? Again you can consider here how we have to differentiate this. Nothing have to do. Let's take the minus sign of this one, right? So in this case, this first term is positive, this will be the negative, this will be the negative, right? Otherwise I am going to tell you how you have to do. Just take the minus sign common and then differentiate, right? Same thing have to differentiate. We have 1 upon x, right, cos 1 upon x, right, plus within bracket 2 minus sine 1 upon x. This is what we have here. Next thing I am tell you one more thing here. We have to check the modulus of this function on R, set of real number, right? Set of real number. So in this case what will happen in case of monotonic function? So either we have f dash x greater than 0 for all x belongs to R. This is for all x belongs to R. Listen carefully, right? Either we have f dash x less than 0 for all x belongs to R. But in this case what will happen? Now see, they are dealing in the concept of 0 comma infinite and minus infinite comma 0. Now go to the option here. First option is, this is monotonic on 0 comma infinite. They are saying that 0 comma infinite. They are saying that 0 comma infinite means x greater than 0. Now in this case, can I write here f dash x greater than 0? No, we can't say that in there f dash greater than 0, right? So we can't judge this one, right? Similarly, if we going to consider a minus infinite comma 0, that is x less than 0. So can we consider this on this interval minus infinite comma 0, this less than 0? Mean this strictly these inequalities will not be followed, right? Either this interval or that interval. So we can't decide this is monotonic increasing or decreasing, right? So here the option second is correct. Not monotonic on minus infinite comma 0 and 0 comma infinite. I hope so that was the problem.